According to the fault diagnosis requirements for electric vehicles, electrical system faults may occur during vehicle operation, affecting normal startup. A owner of a Geely Emgrand EV450 found that when using the remote key to enter the vehicle, pressing the brake pedal, and then pressing the start button, the ready light did not illuminate, and the vehicle could not start. The repair station's diagnosis displayed the fault code P113600, low voltage output disconnected from battery. We will analyze this fault in depth and learn the troubleshooting and handling methods for low voltage output faults. 1. Learning objectives. The catalog for this course of study is divided into 3. 1. Familiarize yourself with the components and working principles of the motor control system. 2. Understand the low voltage power supply circuit of the motor controller. 3. Familiarize yourself with the diagnosis and troubleshooting of faults in the low voltage power supply circuit of the motor controller. 2. We will learn today's content through the following 3 parts. Part 1. Familiarize yourself with the components and working principles of the motor control system. 1. Overview of the motor controller. The motor controller of electric vehicles is the core component of the 3 electrics, responsible for acceleration, constant speed cruising, and energy recovery. The motor controller of the Geely Emgrand EV450 is located in the front compartment and uses CAN bus communication. It collaborates with the power system through CAN to facilitate energy transfer between the power battery and the motor. During braking or coasting, the drive motor acts as a generator, converting kinetic energy into electrical energy to recharge the power battery. 2. Structure and working principles of the motor controller. 1. The motor controller of the Geely Emgrand EV450 internally includes a DC, AC inverter and a DC-DC converter. The inverter consists of IGBT modules, high-voltage film capacitors, and a main control circuit board, enabling the conversion between direct current, DC, and alternating current, AC, as well as between different DC voltages. 2. DC-DC is composed of high and low voltage power devices, transformers and signal control circuit boards to achieve high voltage direct flow to low voltage DC energy transfer. The MCU of motor control integrates the motor rotation, temperature and interlock signals, adopts vector control technology to control IGBT, and communicates with external devices through CAN network. 3. The motor controller also includes a cooler, with coolant circulating through pipes to dissipate heat from the internal electronic components. 3. Torque control mode. The motor controller controls the motor's axial torque in 4 quadrants. Since a torque sensor is not installed, the torque command is sent by the Vehicle Control Unit, VCU, and converted into an output current command for closed-loop feedback control. The torque mode requires the correct initial offset angle of the motor rotor to operate. 4. Active discharge mode. Active discharge is used for the rapid discharge of high-voltage film capacitors within the motor controller. The command comes from the Vehicle Control Unit, VCU, or is triggered by internal faults, allowing the electrical energy in the high-voltage capacitors to be quickly discharged through power resistors. 5. DC-DC conversion. The DC-DC converter in the motor controller converts the high-voltage DC from the power battery into a specified low-voltage DC, supplying the vehicle's 1-2V low-voltage power system. The low-voltage setpoint comes from the Vehicle Control Unit, and the actual output is typically around 1-4V, providing power to low-voltage devices and charging the 1-2V battery. 6. System diagnostic function. In the event of a fault, the software puts the motor controller into a limited state based on the fault severity, including active short circuit or freewheel mode. The limited state has 4 levels of power, torque output restrictions. The PEU software provides diagnostic communication functions based on the ISO 14229 standard. Part 2. Understanding the low voltage power supply circuit of the motor controller. Main components of the low voltage power supply circuit of the motor controller. 1. Power module provides low voltage power, typically supplied by a battery or other power devices. 2. Fuse, used to protect the circuit from damage caused by overload or short circuits. 3. Connectors, used to connect various components, ensuring stable transmission of power signals. 4. Voltage regulator, responsible for adjusting the input voltage to the operating voltage required by the controller. Part 3. Familiarizing with fault diagnosis and troubleshooting of the motor controller low voltage power supply circuit. 1. Fault symptoms. 1. Motor cannot start. The motor controller fails to receive signals properly, preventing the motor from operating. 2. Fault indicator light is on. The fault indicator light on the dashboard, such as the battery or fault light, will illuminate, alerting the user to a fault. 3. Charging abnormalities. There may be issues with charging not functioning properly or extended charging times. 2. Fault analysis. 1. Insufficient battery voltage. If the battery charge is below the minimum voltage required for starting, the motor will not start properly. The battery status and charge can be checked using the Battery Management System, BMS. 2. Blown fuse in the motor controller. Check if fuses IF18, EF32, and the positive terminal fuse of the battery are blown. 3. Poor contact faults in the low voltage power supply circuit of the motor controller. These issues may prevent the motor from starting the vehicle. 3. Fault diagnosis steps. 1. Connect the diagnostic tool and read the fault codes. 2. Check the motor controller fuses. Measure the resistance of fuses IF18 and EF32, and check if the positive terminal fuse of the battery is blown. 3. Check the power supply voltage of the motor controller. 4. Check the grounding resistance of the motor controller. 5. Check the wiring between the DC detection and the battery. 4. Fault elimination. Finally, it was found that fuse EF18 in the interior fuse box was blown. After replacing the fuse, the fault was eliminated. The vehicle returned to normal. The ignition switch was turned on, and the vehicle powered up normally, and could be shifted into gear for driving. The diagnostic tool was connected again to read the fault codes, and clear the historical fault codes. L-level screw plug hole out of the oil. Through this course, we have deeply studied the relevant knowledge of circuit fault diagnosis and troubleshooting for motor controllers, covering the composition of motor control systems, understanding of low-voltage power supply circuits, and the steps for fault diagnosis and troubleshooting. We hope that everyone can master these contents proficiently and apply them in practical work to improve the efficiency of fault handling.